okay, let's solve this problem. We're given an array and we have requests. Basically, a request is a range, and it tells us add all the numbers within this range. So we'll add. Okay, let me show you. So we'll add the numbers nums I, nums1 plus what is this? Nums2 plus nums3. Okay, if you can make sense. Okay, nums3. This is for the first request. And for the second request, we do 0, 1. Basically, nums0 plus nums1. And at the end, they ask the sum of the results of all of this requests. So basically, let's say the answer 1 plus 2. We need this. In other words, we have nums1 plus nums2 plus nums3 plus nums0 from the second request, nums1 from the second request as well. So we need this. This is our answer. Let's call it x. So what is the task? What we should do? We have to permute this nums in such a way that this x, this value, is going to be maximum. Now, how would you do that? That is really, for this problem is medium, but the idea is actually easy. It's only medium because of the implementation. So we have nums1 and nums1 and nums2, nums3, and nums0 in this sum. Okay, the request does not change, so it will be same. So we only permute nums. Even if we permute request, if somehow we mistakenly understand that we should permute request, it wouldn't change anything. So by permute, I mean they change the order of nums. So we have to change the order of the values in nums in such a way that this request, this sum at the end, is going to be maximum. And the problem warns us that the answer may be too large. So we have to return modulo 10. We'll deal with that. So how do we do this? How do we permute nums for this problem, for this input, so that it will be maximum? Like, the logical thing is that nums1 here, you can see it appears twice more than other values. So it contributes to this sum more than other value. So we have to give him the largest value. In this case, it should get 5. And the remaining nums2 and nums3 and nums0, they appear same time. So the frequency for them same, it doesn't really matter. So we take the next largest value, which is 4. We give it one of them, and then we take 3, and then we take 2. So we have here 10 and 19. So that is the idea. So we sort the numbers. Let's actually look at the next input, just to really drive the point home. So nums and request again. So in this test case, I'll take it. Okay. So we have only one request, and we have to add all the values in this range. So it just says nums0 plus nums1. So they appear the same number of times. It doesn't really matter. So let's give nums0 the largest value, 6. Let's permute the value. When I say that let's give this nums0 the largest value, but basically said that, okay, let's permute the nums in such a way that the 6 will be the first value. So it will go into the nums0. So this is going to be 6, and to nums 1, the next largest value is 5. So let's give this, and it's going to be 11. And let's now look at the last input. We have 1, 2, 3, 4, 5, and 10. And we have the requests. Okay, we have, this is a little, there's going to be a little, okay, how many numbers? This will be too long. So I'll omit nums. Instead, I'll write the indices. So the first request is 0 plus 1 plus 2. This is for first request. So this is for first request. And then let's add 1, 2, and 3 plus we have 1 from the last request. This is second, and this is the last request. And this was the first one. Now you can see, let's write the frequencies. 1 appears 1, 2, 3 times. This is the frequency of 1. Let me do it actually all the way around. 1 appears 3 times. 2 appears 2 times. So 0 appears once, and 3 appears just once. So 1, it contributes more than any other value. So we have to give the largest value to 1, which is 10. So it gets 10. So we will permute the nums in such a way that the 10 will stand at index 1. And then next comes 2. So it appears 2 times in the requests. So the next larger value is 5. And for the next one is 0, the next one is 4, and for the last one we're going to give 3. So this appears 3 times. 3 times 10, this contributes 30, and 2 times 5, this contributes 10, and this contributes 1 times 4, 1 times 3, a total of 47. So this was the greedy idea. The number that appears, the index basically appears most in the request, should get the largest value. So we have to change the order of num such that the largest value should stand at an index such that this index appears most in the requests. So the real challenge, which now we come to, is not to figure out this greedy idea, but was actually to how do we count the frequency. So, well, you might want to say, okay, let's just, for the first request, it says 0, 1, and 2. Let's go and let's keep a frequency array. Okay, that's a nice way to start. So we'll just increase the count of 1, and then increase the count of 2, but increase the count of 1 and count of 2, and this way, right? And then we would process the second request, 1, 3. We would go from 1 to 3 and increase all of them. But this is not efficient. So this, I love this word, but it's not efficient. It's because it will be slow. The request is of length 10 to the 5, and request, okay, and the start and end could be n, and n is between 1 and 10 to the 5. Now what if you have something like that, 1, 10 to the 5, like this request, let's say 10 to the 5. This would be a on squared, where n is 10 to the 5, so it would fail. While you're counting, you would fail. So, but how do we count then? Now, how do we count the values, the indices in the request? So we have to basically say, okay, how many of this index, the request, covers 1? So you can view this request as, since they're continuous, as an interval. So let's say from 0 to 2, and from 1 to 3, this is 1 to 3, and the other one is 1, So I don't know how to draw this, but from 1 to 1, let's just say it this way, from 1 to 1, right? How many intervals, this is an interval, how many intervals covers 1? So that's the question you would ask, right? There's one interval that covers 1 here. This interval is just the start of it, and this interval, it's both start and end of this interval. So there's 3. So that is exactly the count of 1. So we have to find the number of intervals covering 1. So this is sort of an interval problem now. So how do we do this though? For example, how many intervals covers 0? Only 1. How many covers 3? Only 1. So how many covers 2? This interval and this interval. So here we have 2. So let's count this. Let's do that. How we'll do this? Now there's a way that you can do it actually easily. You can have the frequency array. Okay, let me show you. Let's say how many numbers we have. Okay, 6 numbers, right? So we're gonna have like 0, 1, 2, 3, 4, 5, 6, and okay, this is actually more than enough. We don't need this. We just need one more spot. I'll tell you why. We will increase for a range left and R. So left and right. So this is basically a request. For example, 0, 2. For this, we would increase the frequency. We could frequency array. This is our frequency array. We would increase the value at 1. That means, okay, there starts a interval. So we say frequency L plus 1. There starts an interval. And from now on, this interval might cover other values until it goes out of its range. It goes out of its scope, right? So basically frequency, then we say frequency right plus 1, negative 1. So that means at this, we just negative 1. Okay, this is nonsense. Negative 1. So this means at R plus 1, an interval ends. There was an interval that just included the R, and now at R plus 1, it just ended. So with this idea, let's do, okay, the last request. Let me actually try it nicely here again. 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5, and 6. So since we access an index to the right of R, so that's why we have a spot here that is more than, when we initialize, we'll have n plus 1 as the size of our frequency array. Now we have 0, 1, 0 and 2. That means 0 and 2, right? So what this means, we're gonna increase the value here, and we're gonna decrease the value here. So let's do that. So we have 1 and we have negative 1. So by the way, these are initialized 0, but I'm just gonna leave them out. 1 and 3. For 1 and 3, we're gonna initialize the value here, and we're gonna increase the value here and decrease the value here. So let's do that. We're gonna have 1 and negative 1 here. For 1 and 1, we're gonna increase the value at point here and decrease the 1 here. So we're gonna have 2 here and a negative 1 here. Now over this array, so you can see what it tells us. It tells us that at point 0 there starts an interval, right? At point 1 there starts 2 interval, and actually it's not starts, but from this point 2 interval passes. At 2, that means from this point, actually in this point, an interval ends. So an interval ends. So that's why we don't count that interval. That interval does not cover 0.2. So then we do a prefix sum over this array. Let's do now prefix sum. 1, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 5, and 6. So we're going to have 1. So 2 plus 1, we have 3. So 0.1 is covered by 3 intervals. 3 plus -1, we have 2. So you see the 2 is only covered by 2 intervals. This one and this one. At this point, there was an interval that was out of scope. Which one? It was this one. That ended here at 2. So when I said ended here, it sounds weird because we have an interval from 1 to 2, and we decrease the frequency of index 3. So when we have an index 3, -1 at index 3, we say that an interval ended at index 3. But it sounds weird because it looks like it ended at 2. But if we say that it ended at 2, that means it does not include that. But since the right end is inclusive, we don't decrease this value because this interval covers 2. If we decrease it, it would miss this interval while it covers 2. So that's why we decrease 1 plus, so right plus 1. That was the reason we decreased that. So at this one here, we have 2 intervals that covering the 0.2. And then we keep going. So 2 plus -1, we have 1. So 3 is only covered by 1 and 3. So you can see there's another -1, meaning that here ends an interval. So basically, before this 0.3, there was an interval that ended at 2 and included 2 and ended at 2, not 3. So that's why this interval does not cover 3. So here we have 1. So then for 4, we're going to have 0. There's no that covers 4. For 5, we're going to have 0. So here stands 0 and stands 0. For 6 does not really matter. We don't have even 6. So we only added 6 not to access an integer out of bound, an index out of bound. So this is our array. Now it says 1 is covered by 0 is covered by 1 interval. In other words, 0 appears once, 1 appears 3 times, and 2 appears 2 times, and 3 appears once. So after we get this frequency array, we would sort it in decreasing order. We would have 3, 2, 1, and 1. So then we would assign to 3 the largest value in nums, which is 10. So we say, okay, 3, there's a value that appears 3 times, and we assign 10 to this. This will contribute 3 times 10. And then for 2, we would say 5. For 1, we would say 4. For this one, we would say 3. So for this reason, we actually sort nums array in decreasing order as well. So we just say 10, 5, 4, 3, 2, and 1. And then we multiply the corresponding indices. So this values, we stop here because we don't have anything here. It can go on, but these values are 0. So we stop here. So this will be the answer. That's how you do it. The hardest part, which made this problem have an acceptance range of 38.5, is this actually. Not the idea of finding that the values, the indices that appear most will be assigned the largest value. That was quite easy. But this part, if you were in a contest and if you wouldn't, and if you struggle with this part, because you would get TLE if you didn't do a prefix sum over the frequency array. Now let me actually show you the code. Okay. Then this is the code. So we have now n, the number of values in nums, and frequency array. Just was said, we have one more element, and then we have the frequency. We increase this one at 0 and decrease this one here, r plus 1 basically, and then we do a prefix sum over this, and then we sort the prefix array and we sort the nums array, and I've just initialized it long, but we have to return integer just to avoid this overflow issue when we're computing. You can use integer as well, but you might do some casting here. And we have the mod. Remember the problem said to take mod, and if frequency is 0, we just break. This was what I said here. You can just stop here. It's okay to move on, but you can just break. There's no point. And then you say answer and the frequency I times nums I, and you take the mod and then return the answer. Yeah, that was a good problem. I hope you learned something in this case. You can use this, I don't know what to call it, like trick or something. I don't know if you would want a more explanation on that, but you will see this in most problems where you're dealing with intervals or some sort of events that has a start and end time, and scheduling problems and stuff like that. I guess they call it sweep line or something. I don't know what they call it with this technique, or this is just some way of dealing with this problems. So I hope you learned this, and we'll use it next time. Okay, see you in the next videos.